Well, hello YouTube. Things look a little different. Trying out this other camera. It has a wide angle lens. It's a GoPro ripoff. But unfortunately you can see all the crap that I have on my table. The good thing is I'm not going to go out of frame unless whatever I'm working on completely falls off the table. Anyway, what we have here today is something, well, I'm not quite sure what it is. Or what I should say is I'm not quite sure what its original purpose was. I have a good idea of what it is. I found this on eBay. Paid probably about 30 bucks for it. And it popped up in my search. I have a search saved for Minneapolis Honeywell. Okay, so it looks like a small briefcase with a window in the top of it. And you can kind of see stuff inside it. On the back, we have an on-off switch, a power connection, and a knob. What appears to be the model number, W234A1K1 115-60, which I am assuming is 115 volt, 60 hertz. There is another tag on here that is illegible. I would assume that would possibly be an acceptance sticker or just manufacturer. There is nothing on the bottom except for some little feet. Now let's open it up. And this is where it starts to look like some kind of quack medical device. Which it may have been. I'm not really sure. It was sold, the listing had it as a Minneapolis Honeywell rectifier device. Presumably because the only markings on it, that is the only tag that is on it. And it says Minneapolis Honeywell Reg Company, which is Minneapolis Honeywell Regulator Company. And 96-894, that's definitely not a date code. What we've got, when I first saw it, I thought, okay, looks like an electrostatic air cleaner. Very plausible, but why? Why would you have a portable little, maybe it's an ozone generator? Also possible. But again, why would it have a window in it? So if we look at the circuitry a little bit, such as there is, there's not much to it really. Have our power coming in the center here. It goes directly to this small fan on the side, which spins freely. This whole thing looks like it was kind of handmade. Like this piece here isn't even straight. It's not bent, it's just not straight. It's at an angle. But we have our switch, which is a double pole switch. Anyway, the motor, fan motor, is connected directly to the plug, and as are these two small light bulbs down here. We have what appears to be a high voltage transformer. We have two selenium rectifiers. We have two selenium rectifiers down here, these two long sticks. And we've got that corrosion. Got to clean that off. There is a resistor, which is hard to see. Two what appear to be capacitors over here. We have our grid plates, And we have a wire that is on this frame right here, and two what appear to be grease filters from like a stove. They're just a mesh, aluminum mesh, that slide down in here. There's one on this side and one over here. They're not connected electrically to anything in any way. They're just there. Let's see if we can get a closer look. That is the resistor that I was mentioning. It says on it, let's see, HBGPA BBM 10 meg 15%. Oh, would help if I was actually probing the end of the resistor and not the phenolic board underneath it. My presumption why it starts high and it's going low is because it is in circuit still, but we're reading little over 10 meg, so the resistor is definitely good. The capacitors, on the other hand, unfortunately, they're turned sideways and I can't really read what the value is supposed to be. I can see MMF, which is microfarad, which would be a picofarad. I cannot read the value of them or the voltage value of them. So that's going to be interesting. And our little rectifiers down there are just sticks that clip in, and if you saw the label originally, you have to put them in the correct manner, obviously, or else something's probably going to explode, which it might anyway. We don't know yet. So what I'm going to do is I'm going to do a little bit of disassembly here, because we need to clean this up because there's some corrosion down in there, especially the ends of the rectifiers and on the, well, I was going to say the potentiometer, but it's basically being used as a rheostat. And let's see, what else? I'm going to disconnect these 3 white wires. They're just held on with thumb screws because this center grid just sits in here. Presumably it can be taken out for cleaning. All you have to do is disconnect the wires and that's it. And these 2 filters also come out like that. And the way this is set up is there is a tiny hole maybe about an inch in diameter, a little bit larger than an inch on this side. The air travels across and it gets blown out like a, maybe 3-inch hole on the other side of this fan. On the front of the box, there's a small hole right here. I'm not sure for what, whether that may have been at one time a power indicator. Just going through my head trying to figure out what this would have been originally for. And other than being a portable ozone generator or something like that, it's not going to be moving enough air to be an air filter. My guess is this may have been used by salesmen that were selling or trying to sell electronic air filters, air cleaners. Because the setup of this is very similar, and I'll bring it in a minute, but is very similar to the grid arrangement in a standard electrostatic air filter system. My guess is possibly, especially looking at this, it's very like yellowed inside, especially these filters here, that perhaps the salesman would have, I don't know, lit a cigarette or something, held it in front of the small hole, let the smoke be drawn through it, and the hopeful customer would see that no smoke is coming out, that it's being trapped by the filter. I don't know. This hole in the front, which is directly after the second filter, the air flows in this direction, could have been for some kind of particulate meter. I'm not sure. I'm judging by the looks of this. I mean, it's got selenium rectifiers. I'm guessing this is at least from the 1950s, if not older. So, did they even have something like that back then? I don't know. Anyway, I will go ahead and take this apart off camera because there's not much to... There's 3 wires I'm going to take off, and we'll be back. Okay, so I have the grid assembly removed. You can see just how filthy that is and discolored, especially on the front of it there. Now I'm not going to take this apart and clean it just yet. I'm going to see if I can figure out how and if it works first. Oddly, the light bulbs are loose. So here's another theory. This yellowing, all this discoloration inside it, may have been because whoever had this previously, I'm not including, say if this was originally used as a salesman, by a salesman, that they would do whatever they would do in their spiel to the customer. But I don't think that that amount of testing would cause like a light bulb to get to be like that. And what I'm thinking is somebody had this and was using it for an air filter and loosened the light bulbs up so the whole thing isn't glowing all the time. Because this one here is a 10-watt bulb, and this one is a 6-watt. So, and both look to be good. Yeah. So, that's another theory. I will wipe off the light bulbs. The rest of it, I'm not going to clean yet. So, I'm going to attempt to remove the rectifiers off camera. And we'll bring something else in here real quick to look at. This is from my old Sears air cleaner that I have. And I have a video on that. It's an old video. But anyway, this is the air flows through from this side. It has a pre-filter very similar to these. It's a washable aluminum filter. And as you can see, it is also made with like plate arrangements, and it does have very fine wires as well. However, and the grid that's in the back is actually a charcoal filter that's the output side of it. It doesn't have one of these on both sides. The difference between this And the other one is we so conveniently have the schematic for it, as it came off the back of the unit. And this is what they called the electronic cell. It is only connected with the high voltage and the ground. And all this circuitry over here is basically just the motor control for the fan. It has a 3-speed fan. And this is the high voltage power supply. Red goes somewhere. I think it's on the other side. Yeah. Red goes to here. And the ground just sits right here. And that is all that is. The plates are electrically separated. So if I take it, now watch this prove me wrong, but if I take it ground, we have absolutely no connection whatsoever between the terminals. So the electrons flowing between positive and negative, or negative and positive, are what attract, and you can see this needs cleaned. But you can see how the plates have a layer of fine dust on them. And now my finger does as well. Okay, here we go. So this is what we have in the Minneapolis Honeywell. And we'll compare it to that. So our line comes in, goes directly to our fan motor and the 2 light bulbs. So I just kind of scribbled those off to the side because those really aren't important. Have our double pole switch going through our rheostat to the primary side of the transformer. From the secondary side of the transformer, it goes directly to the center terminal right here on the plates, and the other side of the transformer goes to the 10 megohm resistor through the 2 rectifiers and to the 2 capacitors. Now, this side here, after the rectifiers, this side would be positive. Let me just make a note of that. I made a note that the GE marking on the rectifiers was the positive terminal. So that would be positive, that would be negative. And so our positive is over here, and that is going to our wire in the front, right here. Remember, the airflow is going this way, so that's going to be positively charged ions. Our negative is coming back to, where is it coming to? Oh, this terminal up here, which is connected to the larger grid plates. So that would be negatively charged. And between the two capacitors, we're also tied to the other side of the transformer. So that's operating in a different fashion than this one did, because this one just connected ground to one side of the plates, high voltage to the other side of the plates. I'm not sure where the wires are as far as the other unit goes, because those are integral to the cell. It's not a separate part like it is on here. Okay, so I'm just looking at this other cell. And the wires are connected to these ribs on the side, and they are connected to positive. So they get kind of a positive bias as well to charge the air as it's going across. These are our little rectifier sticks, and I had marked the GE logo was positive, and you probably can't even see that because it's so dark to begin with. But I googled that. The part number on here is 6RS6PH238TEB1, and of course did not match any documents. So hopefully these are good. I tried checking them with the multimeter. These are high voltage diodes, so most likely the multimeter is not even going to be able to do anything with these. It's probably going to be very difficult to see it, but there is a little tag on here. It says Underwriters Laboratories inspected gas tube sine transformer, and there is a part number on there too, A3024 it looks like. So this is actually just a neon sine transformer, or, well, I'm not sure if it would be considered a neon sine transformer. Normally those are center tapped, whereas this just appears to be, well, a step-up transformer. Let's go ahead and drop, well, let's try not to drop anything, to be honest. Again, I said I cannot test these capacitors. I have one of these gadgets. And if I connect across there, it really, well, cap is leaky, ESR is too high. Let's try the other one. Reset, ESR too high, 0. Because, as I said, these are picofarad capacitors. So most likely this thing can't even read that. It just thinks it's a dead short, or not a short, whatever it's thinking it is. So let's go ahead and put our rectifier sticks back in. Let's see, so we want minus, plus on this side. And these just snap into what are similar to like fuse holders for a glass fuse. And our other one is going to be positive towards this end, and this one's a bit strange because it snaps down on this side then in on the back. Okay, that's at a bit of an angle. In. That's the other thing I wanted to do before we hook anything else back up, is check our transformer. Okay, so our output is going to here, to the switch. Where's our other one going? Here. Or not our output, that's our primary. So we've got about 5.2 ohms on the primary. Now the secondary is going here and here. And we're getting nothing. Nothing at all. Our secondary winding may be open. Let's put it together and see what happens anyway. Why? Because we can. Let's make sure our switch is off. Switch is off. Plug it in. Now it shouldn't really do anything right yet because all we've got at this point are the light bulbs and the fan. So see what happens with that. Well, that much works. Turn our switch on. See if anything goes bang. Didn't seem to do anything really. Well, let's put our potentiometer halfway up. See if that does anything. Well, there's no smoke. That's a good thing. You know what I think I'm going to do? Wait, did I turn it on? Yeah, it's on. Okay. So let's go ahead and turn up our potentiometer. Nothing. Oh, I think we are getting something, actually. We're not really showing any difference in amperage, but I'm not sure if we're going to be able to see that. Probably not. Let me actually stop the video and go ahead with my phone. And we'll see if we can focus in on those light bulbs as I turn up the transformer. So I've replaced the light bulbs with two identical 4-watt light bulbs. I also straightened up and cleaned the corona wire off, as well as these pillars that are behind the wire. So let's see if I can tame that down a little bit so we can see the filaments. Okay, gonna lock that, and we'll turn it on. And as we turn up the power, so I'm wondering if the light bulbs being in there are not simply for the fact of a visual indication that the unit is actually working. One thing I can say for sure, with the filaments dancing around like that, I don't think these light bulbs will last that long. And I think that is definitely what this is an ozone generator, because if we open it up, definitely smell the ozone. I'm going to close that back up and shut this sucker off. And with just that short amount of time that I had the lid open, I could actually taste the ozone. So this thing works, and it works well. And again, I don't know of its original purpose, whether that's what it was for as an ozone generator, or if it was some kind of demonstration unit. So I unscrewed the light bulbs again, and it's not going to focus, but we can actually see the corona discharge. Now, it says do not operate with the cover open, but there's not really going to be anything to see. So, well, I'm actually surprised it worked without any major repairs. So there we have it, a Minneapolis Honeywell portable ozone generator. If anybody has any more information on this, let me know. Thanks for watching.